I want to start this section with a picture of some Roman glassware made in the 4th century. This is the Lycurgus Cup. It's shown here illuminated from the side, and as you can see, it appears to be a lovely green colour. If we look at the same cup illuminated from behind, it appears to be a reddy purple sort of colour. How can we understand this behaviour? Of course, we understand it using harmonic oscillation, in this case, driven harmonic oscillation. What's being driven here are tiny metallic nanoparticles. The electrons in these metallic nanoparticles can resonate at the optical frequency. So if you illuminate this cup with white light, some frequencies in that white light spectrum will be resonant with the electrons that jiggle about inside the nanoparticle. This jiggling of electrons will then re-emit that light of that specific wavelength, and it'll be scattered all over the place, and less of it will be transmitted through the cup. So the nanoparticles in this cup, we then realize, must be resonating in the green, so only the green light that comes from the side will be scattered towards your eyes. The light that's left over will be the red and purple light that gets transmitted through the cup, and thus we can explain the dichroism, or two-coloured nature of this glass. Here are some microscope images of individual metallic nanoparticles, in this case silver nanoparticles, and as you can see, different particles have different colours. They're all illuminated with white light. Now, depending on the size of the particle, they are resonant at different frequencies. In the homework question this week, we'll do some electrodynamics and calculate the resonant frequency of a sheet of metal. When you do this calculation in the homework, you'll get an answer which will be in the ultraviolet rather than the visible. The difference is that in the homework question we're considering a big sheet of metal, whereas here we have little approximately spherical particles, and that reduces the resonant frequency. Nevertheless, the principle is the same, that we are driving electrons in a metal to resonate, and in this case we're driving them with electromagnetic waves. So with that, we'll leave behind nanoparticles and go on and think about driven harmonic oscillation with damping, and we'll go back to our spring and mass system, realizing, however, that although we're using springs and masses, this behavior is universal and can be used to describe any damped driven system.